My name's Dawn Haig, and I'm part of the PIP team. I'm very happy to welcome you to our third Feeding Breeders webinar. Before we start, I'd like to do a quick poll. We'd like to find out if our audience is using the discussion board. The poll is going to pop up on your screen, and you can click on the answer that represents you best. There's the poll. Great. As we wait for responses, I'd like to introduce our moderator for today, Dr. Mohamed Afrouzieh. Mohamed's a research associate for the Poultry Innovation Partnership. Welcome, Mohamed.
Hi, everyone. Thank you, Don.
Okay, so have we got results from the poll? Let's see. Okay, interesting. I've read the discussion, 30%. Nobody's added a question. Nothing to discuss. Don't know what it is. Nobody clicked that. Tried, but don't know where to find it. Didn't have the time. Okay, fair enough. You know, it's summer and everybody is busy. But we thought that there may be some of our viewers that aren't quite sure how to use it. So Mohamed was going to do a little demonstration and just to show you how it works and make sure everybody's comfortable. Mohamed?
Yeah, thank you, Don. So I'm gonna just share my screen with you. Okay, so you have got an email from Feeding Breeders. It's called You Are Invited. And here is your invitation to join the Feeding Breeders discussion board. You need to click on join, and then you will be directed to the feed loop. Here on the left-hand side, you can see peer board discussion board. You need to click on that. And here you can see the webinars for different days. Just pick the webinar that you are interested in the topic. And here you can see the discussion that already happened. Actually, here is the questions that we got during the webinar, and our speakers answered them. If you scroll down, you will see here there is an ongoing discussion. You can just reply to any comment that you would like. Or if you want to make a fresh comment, you can just add your comments here in the comment box. And then if you press subscribe button, you will be notified if there is any new comment on this page. So I hope you can join the discussion board, and that's all. Back to you, Don.
Thank you so much, Mohamed. That was a great demonstration. I hope that's helpful, folks. The discussion board is a really important part of our process leading us to our summit in Canmore. I just want to remind you that in FeedLoop, which is this virtual event platform, you can watch any past webinars that you might have missed, or you can also visit ones that you saw and you'd like to watch again. If you have any questions, under the networking tab, again on the left, you'll see +1 event assistant. You can add your questions there. Our team's happy and ready to help. You can also let us know there if you have any issues with the discussion board that are preventing you from popping on. Okay, again, we're very grateful for our sponsors whose funding makes this possible. I'd like to let you know who they are. Presenting sponsor, Poultry Innovation Partnership and ARDAR. Platinum level sponsors, Aviagen and EW Nutrition. Gold level sponsor, Merck Animal Health. Silver level sponsor, Cargill and Cobb. Student sponsor, Adesio. Bronze level sponsors, New Life Mills, Country Junction Feeds, and Canadian Hatching Egg Producers. Finally, our supporter level and meal sponsors, Chore Time, Canadian Biosystems Incorporated, Alberta Hatching Egg Producers, Richie Smith Feeds, and Alberta Chicken Producers. Thank you so much to all of you. Now, back to the discussion of the day. Our question is, how does feeding interact with other management practices to influence reproductive physiology and chick output? We have two speakers today, and I would like to introduce them. Dr. Grigoi Bedikarat, professor at the University of Guelph and Dr. Ramesh Ramachandran, professor at Pennsylvania State University. Dr. Betta Karat will open our webinar discussion today. Welcome, Gregory.
Good morning, everyone. Thank you for the introduction. And before I start my presentation, I would like to put up a little disclaimer. I am actually not a nutritionist, and I did most of my work on layers. However, as I'll try to bring the message home today, there are a lot of conserved mechanism in terms of the physiology, whether it's a layer or a broiler breeder, and might even expand all the way back to some of the wild and migratory birds. So here, what I'll try to do is to show you a little bit some of our latest results and then extrapolate and expand that to the broiler breeder sides and see some of the practical implications that may be important for the industry. Right, so let me share my screen so I can load up the presentation. All right, hopefully everybody can see that. And I'm just going to turn that video off so it is not distracting. All right. So when it comes here to feeding, obviously what we are looking at is an investment in energy for the birds, but as well an investment in money for the producers. And here I'm going to try to show you that in fact, the feeding strategy, the diet, and the growth of the bird may have some significant implication when it comes to the reproductive performances. So this is kind of my generic first slides to describe a little bit the reproductive axis in chickens, and then we'll use that as a base to see where that nutritional aspect can interfere with the reproductive axis. So typically, in a bird, we'll have 3 levels of control for the reproductions. The brain at the top here called hypothalamus. This is where we have the integration centers, so the neurons that decides whether it is time to activate reproductions or inhibit reproductions. And those centers in the hypothalamus here produce 2 neuropeptides, the GnRH or gonadotrophin releasing hormone, which is the accelerator pedal. So this is really the one that will kickstart and activate the reproduction. Whereas on the other end, the GnIH, with the I standing for inhibitory here, gonadotropin inhibitory hormone, and in this case, it counteracts GnRH. So we can see from the brain, we really have 2 main signals, an accelerator pedal and a brake. And both of those will modulate the pituitary gland that sits underneath the brain to produce hormones that are called gonadotrophin, LH, and FSH. And those hormones then amplify the signal from the brain and targets the gonads. That will stimulate the activation of the gonad. And in the case of the females, that means here stimulations of follicular development. And as those follicles grow, they start producing steroid and peptide hormones that will then act on the rest of the body, but also will feed back to the higher level. So here in a kind of an overly simplified version, we have the brain, the control center, the pituitary that serves as a kind of an amplification site to distribute the signal to the rest of the body, and in particular the gonads, where the egg yolk will be formed and then leading to ovulation. Now, being the center, integration center, the hypothalamus receives all the information from outside, so the environmental cues, and those correspond to photoperiod, so change in the duration of daytime, but also will integrate internal signals from within the bird that will let the brain know whether that bird is actually ready to enter lay or not. So that led to our original model already now quite some time back in 2009, where we really focused on the environmental cues, so the use of photoperiods. And from there, we developed a model showing that when you have a non-stimulatory photoperiod, meaning longer periods of darkness, that stimulates some other hormones called melatonin during the dark time that preferentially stimulates the brake pedal, so that inhibitory pathways, and that blocks the reproduction. So you can see here, when the season is not favorable for entering active reproduction, then that GnRH will prevent the bird to actively enter lay. However, as the photoperiod increases in the industry known as photostimulation, what it does, it reduces the amount of melatonin, so lift the foot off the brake pedal, and at the same time, that increase in photoperiod directly stimulates the brain to produce the accelerator molecule GnRH. So during that transition, now we lift the brake, press the accelerator, and that triggers the initiation of reproduction. And eventually, that bird will be fully mature with a fully functional ovary and will have the successive ovulations or daily egg production. So that was great when we took us some time to put some of the species together. But then when I was started to look a little bit deeper in the light and the type of light, we did an experiment where we lit up some pullets with different type of lighting system. And what we noticed is, regardless whether we are using incandescent, fluorescent, or red bulbs, LED bulbs, the peak in estradiol here, which is an hormone produced by the ovary, indicative of the activation of that ovary, occurred before photostimulation. So the question that's, well, how is that possible? How, according to our model, you need to photostimulate to activate the reproductive axis. Well, from that particular study, what we noticed is a lot of those pullets were actually overweight, or I should not say overweight, they were above the recommended body weight target. And that kind of raised the suspicion for us that, that's interesting. Those layer pullets, as soon as they get a little bit on top of the curve, sexual maturation is advanced. And that brought us here to bring a new component in our model, a new component that will include the metabolic status, or all of those energy reserves potentially. And why we thought that was important to bring it in, because at the same time, some other studies have shown that that inhibitory peptide of the brake pedal was actually a neuropeptide that could stimulate feed intake, and hence, as it stopped reproduction, was stimulating feed intake for the purpose of growth and potentially for the purpose of building up some reserves. So here we already had some hints that in fact there may be more integration between the metabolic status and the photoperiodic control at the level of the hypothalamus. As a matter of fact, we followed that up looking at 3 breeds of layers. So a commercial line, the Lohman LSL Light, our heritage breed here, the shaver breeds, and all of those are Leghorn derivatives, by the way. And one of my own breed here that I maintain at Guelph, the Smoky Joe, that was never selected for egg production. And this is kind of reflected here in the production curve, where we can see the difference in production between those 3 lines. And we use those as a kind of a surrogate for the impact of genetic selection over time. What we noticed, though, is although the age at first egg was different between the non-selected strain, the Smoky Joes, and the 2 kind of more commercial strain here, what was striking is, regardless of age, regardless of the time at photostimulation, all of those hens entered lay within a narrow body weight window, all around here between 1.43 kgs and 1.49. So it's a very small body weight window. That led us to think that, well, maybe body weight is actually a good, reliable, potentially indicator to plan when that pullet is going to enter lay. And remember, as I mentioned earlier, we still also have those external environmental cues like photoperiod. So here I was thinking was that, in fact, we need to coordinate or re-coordinate the body growth with the photoperiod. And if the birds grows quicker than expected, then maybe we need to adjust the time of photostimulation. And maybe on the other end, there is a need to try to slow down that body weight gain to make sure that it reaches its optimum weight at the time of photostimulation. So beyond body weight, and when we looked at that, we say, okay, body weight, that's fine, but you can have two bodies with the same weight, but they're completely different. You may have one with a lot more adipose or a lot more fat, and another one that may be more lean or more muscular. So what we tried to do next, we looked at what if we generate artificially 3 different growth trajectory, one where we would leave the birds totally ad libitum, free access to food, another one where we'll maintain them straight on the breeder's recommended target, and another one where we would feed restrict to slow down growth. And we tested that into 2 strains of layers, the LSA lights, so the white birds, and the Lohmann brown. And what we noticed here, this was quite interesting. First of all, for both the whites and the brown, when we restricted those birds, we delayed the age at first egg significantly. So which means here another indication that there is actually a link between the body status and the entry in lay. Now, if we look at the ad libitum versus the on target, surprisingly though, when we looked at the whites, those whites ate relatively the same whether they were ad libitum or on target. So which means the white birds did not tend to eat excessively. Hence, the 2 entry in lay for those target and ad libitum here were similar in white. However, in the case of browns, here the ad libitum really tended to eat more than the others. And we can see there, this is that curve. And hence, they also entered lay prior to the other group. So from there, we really looked at, okay, there is body weight for sure, but then we also look at the body composition. So using a technology, an imaging technology, dual X-ray, to monitor body weight, we kind of scanned all of those birds, and what we came up from those studies, pardon, is like a fat ratio of about 10 to 15% appeared to be kind of required for those layers to enter lay. Right, so you're gonna say, what about broiler breeders? Enough of layers. So broiler breeders is a different scenario, because in the case of layers, we typically let them eat, the pullets are raised ad libitum feeding because overgrowth or obesity has never been an issue with layer pullets. Now, what we observe with layers is probably the result of the genetic selection to advance sexual maturity, which in fact, advance the growth curve or the growth trajectory of these pullets to reach target. When it comes to broiler breeders, we all know what happens if you leave a broiler breeder ad libitum because of, again, the genetic potential and the fact they were selected for rapid growth. They have a really very strong hunger, really strong need for nutrient, very strong appetite, and that can get out of control, and those birds can develop some issue if they grow too fast, whether it be musculoskeletal system, well, they are not able to sustain their weight. It could be cardiovascular system if the heart is not able to pump enough blood to supply those large bodies, and as well in reproduction. And it has been shown that, in fact, if a bird becomes obese or has too much adipose, that will interfere with the development of the ovary. So hence, in broiler breeders, the goal has been to slow down growth, and this is achieved by feed restriction. However, has been highlighted by the group of Martin Zudoff, the increase in genetic potential, so input growth potential, has outpaced the actual protocol for feed restriction. And what do I mean by that? The birds are getting genetically growing faster and faster and faster, but at the breeder level, the feed restriction paradigm haven't followed through. So what does that mean? Well, and from now on, I'll go over a couple of key studies from the group of Martin Zudoff that I participated in those studies as well, to highlight then what is the impact of playing with that growth trajectory on those broiler breeders. And in that paper here from Sasha van der Klein in 2018, what they looked at is they looked at what if we play with the rearing photoperiod, so during the pullet growth, and we play with the energy that is put in the ration for those birds, whether a standard diet or a high energy diet. And what transpired for that is both here have an impact on egg production, both the photoperiod during rearing, but as well as the growth trajectory. And the key finding is, in fact, that you need to have, as we kind of knew before, under 12 hours of light to effectively set the bird ready for reproduction. If you raise them over 12 hours of light, they become non-photosensitive, aka they don't respond to the photostimulation. Now, the other thing that was very interesting is if we look at the solid lines here, the thick solid lines, you can see that they were on top when it came to egg production, which means that if they were reared with a higher amount of energy available, it actually helped at the time of entry in lay and entry in production. And another very interesting fact from that study is when we look at percent production, sometimes we wrongfully assume 60% means every hen lays at 60%. And in fact, what it turned out to be is either you lay or you don't lay. And that 60% is reflective that, in fact, it's 60% of the hen that are actually entered lay and 40% that are not. And this is captured in this graph here, where again, we can see that the birds that were raised under 8 or 10 hours light during the rearing period, and we're provided the high diet here, all entered lay before the other group. And in green here, if we look at the high that was under 12-12, and you can see it was delayed in the entry in lay, suggesting again that we need to coordinate the photoperiod during rearing with the diet and as well at the time of photostimulation. Now, in another study, recent study published by Martin's group by Adinia et al. In 2020, here in that particular case, they looked at, okay, the impact of changing the diet just before maturation. So just in that before puberty, around the time of puberty. And in this case, those broiler breeders were fed a low or a high metabolizable energy diets starting at 21 weeks of age. So you can see here just before the time of photostimulation. And what does those results show? Well, they show that obviously there was a difference in body weight and in body growth. As you can see here, by 24 weeks of age, the one on the low diet were just under 3 kgs, whereas at the same age, the ones under the high diet were almost 1 kg over their low counterpart. And what does that translate to? Well, if we look at the percent of hens in lay, we can see that that 3 level, kind of 3 kg here, a little bit over 3 kg may be a critical point. And in the low energy diet, by the time they reach 28 weeks of age, only 58% were in lay. Whereas in the high MEI diet, here by 25 or by 26 weeks of age, all the hens had entered lay. So again, bringing that other argument that having that increase in body weight and most likely increase in body reserve right before photostimulation or right before maturation may be one of the best management tools. So moving on now, Dr. Afrouzeye or Mohamed was chairing this session, published a paper last year, where in this case, they said, okay, so what is more important? Is it the growth during the pullet, or is it that particular time frame right around puberty? And in this case, using Martin's precision feeding system, they generated 10 growth trajectories with 2 levels of early growth. So during the kind of early pullet, so the immature stage there, either standard or high, and then they designed 5 levels of late growth around puberty that generated 10 different growth trajectories. And what was interesting from those results here is the early growth period did not have much of an impact here on the age at first egg. So meaning here, having those birds grow faster during the early stage did not have really a carryover effect. What did have an impact was the level of feeding and the level here of growth right before or right around the time. So you can see here between 16 and 24, right around the time of puberty. Similarly, here, what we look at the body composition, it was also beneficial when it came to the shank length, meaning here it helped the birds achieve optimum body frame size, but also was resulting in differences in fat, in adipose, with an increase in adipose tissue. Now, interestingly, when I was talking about layers, I was saying that we think around 10–15% fat is important. In that particular study, they put the threshold at around 8%. And again, that's not offsetting. It's probably could be with a difference in the analytical methods, but the theme is the same. There seemed to be a threshold level of adipose or fat that needs to be reached in order to adequately stimulate the reproductive system. And finally, here, a recent paper from Mohammed, and this is something we've been looking after, chasing, myself and as well Professor Ramachandran, is what are the mediators between that metabolic status and the brain, and the metabolic status and the ovary. And in that really recent study from Mohammed here, they looked at blood metabolites in plasma. And they compared hens at the pullet stage versus hens in lay. And as well, they also compared hens or broiler breeder hens that entered early in lay versus broiler breeder hens that entered later in lay. And they did a big profiling of the metabolites in plasma and identified quite a few differing factors or different metabolites. But here, 15 were identified at potential marker during the transition from pullet to hen, whereas here another 18 were identified at potential marker comparing an early layer versus a late layer. Now, grouping those, and this is when it gets very interesting, because obviously when you throw a big catching net like that, you're going to catch a lot of unwanted fish. And here you really need the analytical methods to try to sort through that amount of data. And to me, this is one of the key aspects. If we looking at the pathways or the physiology behind it, the key player here, as we see that big red ball, in both cases between immature and layers and early versus late layers, was the glycerophospholipids metabolism, aka fat metabolism. And somehow it's not surprising, but it's comforting, because that tells us that, as we suspected, really there is something about the fat metabolism that appears to be one of the most important components linking metabolism to the reproduction. Now, in the case of the transition here from the pullet to layers, another one that popped up is the TCA cycle, also known as the Krebs cycle. And in that case here, this is a critical cycle to generate energy from reserve. So here we can see important is the reserves, the adipose or the fat. Second important is extracting energy from that fat. And as well, along the way, also some amino acid metabolism were identified as being kind of key component between an early layer and a late layer in broiler breeders. So what does that mean? Well, and this is perfect, because this is actually my last slide, and it's going to nicely link with Ramesh's presentation. Initially, when we looked at the brain, here you can see our brake pedal, the accelerator, and those two are actually linked to other neuronal network. Here you can see those one, the orexigenic and the anorexigenic. And what do those do? They control feed intake. So here there is a direct interconnection between reproduction and feed intake. But we still need to have signaling from the body indicating the status. And we dug through several potential pathways. And one that appeared the most promising is actually an adipokine, so a signaling molecule from adipose tissue called adiponectin. And why? Because we believe adiponectin can actually mediate the metabolic status or the reserve status to the hypothalamus that will then in turn control the appetite and as well modulate the reproductive axis. And furthermore, within the ovary, we'll see that adiponectin has also a tremendous impact into the function or the development of the follicle. And I believe Ramesh is going to go in more detail over that. But at the end of the day, one key target here is the liver. Why? Because in birds, the liver is the primary organ that regulates here where the energy is going to be and where it's going to be stored. So hence, the energy, lipids, and glucose metabolism are all here linked at the level of the liver. And we speculate that adiponectin is going to be one of the main mediators of the metabolic status. All right, so this is kind of it for my part. And I would like to just please, if you could just put the questions in the Q&A box. And after Ramesh does his presentation, we'll address all those questions together. And I would like to thank, of course, all of the students and the sponsors over the years that have helped us to reach that level. And thank you very much. Let me try to get back.
Can everyone see my slide?
Yeah.
Okay.
There you go.
Hi, good morning. Thanks. I thank the organizers for inviting me to present our research in this symposium. I have a disclaimer to make as well. I'm not a nutritionist, but I do, my lab works with the broiler breeders, but in a research setting. So, and you will realize that as we go along. I thank Grigori for a very nice introduction and also the segue to lead into my talk. The optimal output, the output that we expect from broiler breeder hens is fertile eggs and the chicks, okay? And if you look at the middle one here, it's something like similar to a leghorn hen where we have such a streamlined selection of follicles in the ovary, where you see a very nice cohort of pre-ovulatory follicles denoted here as F1, F2, F3, F4, F5, and then a very good reserve of pre-hierarchical follicles at the center. And this is what we ultimately want to achieve without much of an intervention, ad lib feeding, or feeding to a level that will support consistent egg production over the entire production lifespan. But on the other hand, what we are confronted with broiler breeders is either undernourishment or overnourishment. And you can see a part of the intestine that I'm showing here, the mesenteric fat here, not just the adipose, the fat pad. We can look at the adipose around the visceral organs as well. And in an undernourished animal, what you can see is a very thin layer of adipose, and you can look at the ovary that is completely regressed. And on the other hand, if it is overnourished and if there is excess energy that is not turned into eggs, here you find almost like a buttery spread around the intestine. You have so much of mesenteric fat. And then I don't need to explain what we are showing here on the right side. It's like excessive recruitment of follicles, both at the pre-hierarchical level as well as at the pre-ovulatory follicle level. So where you see double hierarchy. And we may not see this kind of a binary output, like either completely regressed ovary or a full complement of excessive follicular recruitment, but everything in between the undernourishment and overnourishment. So my lab is studying the ovary, adipose, and the liver to see what is actually going on if an animal is receiving an excess amount of energy. These, no doubt, we know we are selecting these animals, so they are eating so much feed. And what is actually happening to the energy in terms of the in organs like ovary, liver, and adipose. And I just want you to go back into the history or the background behind the uniqueness of chicken model. And I don't need to explain the first bullet point. We all know that. We have been selecting for growth in the broiler chicks. We want to achieve very good feed conversion efficiency and rapid growth rate with a lot of muscle mass and good skeleton. So we get 40-fold increase in body weight in less than 42 days. And this is obviously putting pressure on the broiler breeders, the parents. And as I showed in the last slide, we encounter with a lot of visceral adiposity if we feed these broiler breeders in excess of what they need. And I also want to point out from the previous talk from Grigori, he talked about the TCA cycle, okay, the tricarboxylic acid cycle, and that is key for the energy metabolism. And we need to understand that all avian species, not just the Gallus species, all avians have a very high blood glucose level when you compare that to mammals. And this is physiological. It's a physiological hyperglycemia. And all of this blood glucose is not necessarily coming from the feed. It is coming from the liver. The liver is making a lot of glucose from non-carbohydrate source as well, gluconeogenesis, to maintain such a very high level of blood glucose level. And the same way, the liver, another important organ, not just for glucose production, and it is also the site where lipid synthesis happens. And the lipid that is synthesized in the liver is deposited in adipose tissue, and also it is the same place that synthesizes yolk precursors that are essential for the growing ovary. And this is just a background. And now let's look at what is actually happening in the adipose tissue. And all you're seeing here is a histological section of an adipose tissue. It looks like a cobweb, right? And all you're seeing here, I don't know if you can see the cursor that I'm moving around. That's the plasma membrane. And this is an entire adipose site, one adipose site. And you see it's all empty inside, right? And it is empty because when we process, we remove all the lipids. So in other words, 95 to 98% of the cytoplasm is just lipids stored in those adipocytes. And all these blue dots here are the nucleus that are all pretty eccentric, staying outside almost along with the plasma membrane. And what I want to drive home here is the adipose tissue is a dynamic organ. That's what we now know in the last 20 years or so, where the cells can increase in size or decrease in size. They can proliferate, and based on the energy reserve or based on the lipids that are being transported from the liver and deposited in here or resorbed from here as well. So it is such a dynamic organ. So it is not just for storage of energy, but it also produces a whole bunch of hormones and cytokines, collectively called as adipokines. And I have put them in two categories in here, okay? The one on top is those adipokines that are documented and we know their function in chicken. On the other hand, there are a whole bunch of them, and even I put plus others because I don't want to list another 100 of them in here, and that either are not discovered in chicken or we don't know what exactly they are doing. And this is partly because of complex genomic structure of many of these protein hormones found in human. And on the other hand, we now know about adiponectin, camerin, TNF-alpha. Very recently, we discovered TNF-alpha. And visfatin is actually an enzyme. It is ubiquitously present, not just in the adipose tissue. And I'm going to talk a little bit more about adiponectin, how it is connected to to obesity, or I shouldn't say obesity, excess deposition of fat. And adiponectin is the most abundant hormone in blood circulation. And typically hormones are measured in nanogram per, per mil. But in the case of adiponectin, it's about 1,000-fold higher. And it is true in humans that 1.9 to 17 micrograms is found. And it is only, it is the number one most abundant hormone next to, thyroxine. And very interestingly, in humans, what they found was obesity or type 2 diabetes or people with having dyslipidemia or even polycystic ovarian syndrome, there is a negative correlation. Incidence of obesity and plasma adiponectin levels are negatively correlated. So the higher the obesity, the degree of obesity, lower the adiponectin level. And it's kind of paradoxical because you may expect, okay, in obese patients, you will have a lot of adipose tissue. It must produce more and more adiponectin. Apparently not so, especially with the adipocyte getting hypertrophied, they produce less and less of adiponectin. And in rodent models, if you overexpress this hormone, you can feed those mice with McDonald's type of diet with a lot of fat and sucrose, but still those mice are protected from developing diet-induced obesity or type 2 diabetes. The most important function of this hormone is to increase insulin sensitivity, glucose utilization in the muscle, and also in the liver, and particularly lipid oxidation. So these are the most important function, but it has many pleiotropic beneficial effects related to inflammation, angiogenesis, and so on, which I'm not listing here. So what about chickens? So what we found was adiponectin is expressed in adipose tissue. Of course, that's the number one organ, and that produces most of the adiponectin. But in addition to that, we also found adiponectin gene is expressed in several other tissues that are important to us, like liver, pituitary gland, like what Grigor was mentioning, the brain, and also to some extent in kidney, because kidney is also an organ that produces a lot of glucose. And this is at the gene level. So we had some struggle because chicken adiponectin is completely different from human or mouse adiponectin. So we had to develop our own reagents. And using the antibodies that we made for adiponectin, again, we found chicken to be very unique in that the adiponectin protein or hormone in blood circulation is actually a multimeric protein. It is this monomeric, the single unit of adiponectin is only 30 kilodalton protein, but it does not circulate in blood circulation as a monomeric form, but rather it complexes itself and forms a polymer. And that polymer is about 720 kilodalton in size that you can see here. And we saw the same thing in plasma, adipose tissue, and to some extent in skeletal muscle as well. And we developed an immunoassay and quantified plasma concentrations of adiponectin. And you can see for broiler breeder hens, one on the left with the restricted feeding, and one on the right is the unrestricted ad lib feeding. And you can see adiponectin is like about 1/2 like in blood circulation. And so now we know plasma adiponectin is lower in broiler breeder hens that are ad libitum fed. Okay, and obviously you can see, such an excessive amount of adipose tissue, the cells are perhaps hypertrophied. So how are we going to change this? Okay, and as I showed in the previous couple of slides, adiponectin is not just expressed in adipose tissue, but in multiple tissues in the case of chicken. And the organ of interest for us is obviously ovary, right? And the ovary in ad lib fed broiler breeder hens, they also have excessive amount of pre-hierarchical follicle. So we wanted to know if we take those pre-hierarchical follicles, isolate theca and granulosa cells, we want to know if those cells produce adiponectin as well locally. Why? I'm going to show you eventually that there is a nexus connection among liver, adipose, and ovary because they feed back all the time. and particularly the estradiol that are made from smaller and smaller follicles, pre-hierarchical follicles, they are going to be communicating with the liver to produce more and more lipid, particularly that are those lipids that are needed for yolk development. And what you see here at the bottom is when we took those cells and grow them in culture, we found that those cells contained adiponectin, and they also secreted adiponectin into the cell culture medium. So in other words, we know that this particular hormone can work locally produced hormone can work within the theca cells. And also we wanted to know if we can alter the secretion of this hormone from theca cells. And we tested it with a couple of compounds. One of them is called as pioglitazone. It is a thiazolidinone compound. Without going into the detail, it's an agonist for PPAR gamma, peroxisome proliferator receptor agonist. And that is shown in humans to increase adiponectin secretion. So when we tested that in vitro, yes, it does increase adiponectin secretion. We also wanted to see if another compound like omega-3 fatty acid, eicosapentaenoic acid, and that also seemed to be stimulating adiponectin secretion from theca cells. And we wanted to check the functional aspect of adiponectin in these theca cells from different parts of the ovarian follicle. Please pardon me for showing this slide with a lot of information, but I'm going to distill the information given in this slide. What it does is, if we had to make a recombinant chicken adiponectin because human adiponectin does not work in chickens. So the recombinant chicken adiponectin, when you test them in theca cells, they are attenuating steroidogenesis. That's the message in here. How do we know? We went with a certain signal transduction molecules. One is called as phospho-ERK, and then the other one is phospho-ACC. ACC stands for acetyl-CoA carboxylase, an important enzyme for lipogenesis. And this particular enzyme is critical in the case of theca cells to eventually make lipids and cholesterol for steroidogenesis. So we tested the recombinant chicken adiponectin. The take-home message is in every follicle, you can see the signal transduction goes in such a way to reduce steroidogenesis. And also an important gene that is required for cholesterol transport into mitochondria for steroidogenesis is also affected. We tested not just a recombinant adiponectin, we tested another compound called as adiporon. This is a synthetic small molecule that will stimulate adiponectin receptor. And they also behave exactly the same way as recombinant adiponectin in attenuating steroidogenesis and steroid production in the case of theca cells. All right, these all look very science fiction thing, like how are we going to apply that to practical industry, okay? And we were looking for any other compound. I don't think we can use recombinant adiponectin in chicken. It's so expensive and it's a protein hormone, such a high level in blood circulation. What are we going to do with that? Adiporon, again, it's a small molecule. It's not even in use in human clinical trial at this point. Or maybe it's an early clinical trial, not in clinical practice. And so we stumbled upon a compound called as Metformin, okay? It is commonly known as glucophage. And if you know somebody who has type 2 diabetes, they probably are taking this drug in addition to lifestyle management. And this is the 6th most prescribed drug in the US. And metformin can be given orally, and it's absorbed from the gastrointestinal tract. And where it works is, it works mainly in liver, in hepatocytes. And its main function is by decreasing several signal transduction, altering signal transduction pathways to decrease glucose output. So it is going to decrease gluconeogenesis and therefore glucose output as well. And one more thing it does is it is also going to be decreasing lipogenesis and also increase lipolysis by by changing key enzyme pathways within the cytoplasm. And overall, if you look at it, it improves hepatic insulin sensitivity, decreases liver fat, and decreases, gluconeogenesis. So it all goes in the right direction towards what we need to achieve in broiler breeders. So we designed a small trial in our research farm with broiler breeders to see if metformin can be used to affect egg production. And again, I caution you here, these hens are, of course, they were raised on the float pen until 20 weeks of age, until they are photostimulated. And then we moved them to cage. And we had 4 groups of animals, 4 groups of treatments here, 0 milligram, 25, 50, and 75 milligram of metformin per kilogram body weight. And these doses are way, way lower than what an adult human would take for treating type 2 diabetes. We came up with these dosages using several pilot trials. If you used anything greater than 125 milligram, it knocks down egg production big time. And I'm going to show you the data, especially with these 4 treatment groups. So we fed the animals with a diet containing metformin from 25 weeks to 65 weeks. And what we found is this, okay? So the body weight that we measured, we found along 20 weeks to 65 weeks, you can see the body weight starting to go down even around 40 weeks of age compared to 25 to 75 milligram. And then at the end of the study, you can see, there is a significant reduction in body weight. And most of the reduction in body weight is coming from reduction in adipose tissue. So this is the fat pad weight that we took. And so you can see the fat pad weight is significantly lower in 75 milligram treatment group. And so that contributed most of the body weight decrease. And here you can see a representative photograph of lineup of ovarian follicular hierarchy. And animals that were not given 0 milligram, they were not given any metformin. You can see some double hierarchy here, 2 F1 follicles that could result in double yolk or an internal ovulation. On the other hand, the animals that had metformin in the diet, we saw a more streamlined ovarian follicular hierarchy. And please note here a large number of pre-hierarchical follicles as well, not just the 2 F1 pre-ovulatory follicles. On the other hand, with metformin treatment, you can see much more streamlined, fewer pre-hierarchical follicles. So what is at the end of the day? You can see egg production data here. So cumulative egg production that you are seeing here, we started the drug trial at 25 weeks, right? So the first 5 weeks when metformin was in the diet, probably it was kind of a shocker to the animal's hepatocyte. We did see a decline in egg production during that 5 weeks. But after that, we saw a consistent egg production. Egg production was not lower all along. But if you look from 45 weeks onwards, the control group started declining while the metformin-treated animals had consistent egg production over a period of time, even at 65 weeks of age. And if you stratify this here at different body weight, different metformin levels, you can see, let me move my screen. Yes. So you can see a more tighter egg production figures right here. And you see a significantly more egg production from 75 milligram group and also from 50 milligram group compared to the control. And if you add all the number of eggs that we counted from 25 weeks all the way to 65 weeks, and you can see a significantly greater number of eggs from 75 and 50 milligram group compared to the 0 milligram group. So now you may wonder, all right, I've fed the animals with metformin, right? Is it going to affect fertility and hatchability? And my graduate student, Evelyn Weaver, She actually did all the inseminations, artificial. We kept these animals in cages, so we did artificial insemination, and we did not see any decline in fertility or hatchability at all stages, at all times during the trial period. So this is where we are, and we need to know what is the actual. If I go back to the previous slide, where exactly we should start the drug. Okay, is it just starting all the way from 25 weeks, or we decreasing fat level, even adiposity level, even at the earlier stage? Should we even just start at 45 weeks, or is this the right amount of dose, or can we combine it with any other nutrient that could maximize egg production? Those are the things that we are currently thinking about. And okay, so one element that we've been quantifying several hormones in the blood circulation, how this metformin treatment is affecting those blood levels of hormones, in addition to, along with the steroid hormones as well. And one important thing that I want to focus is on triglyceride concentrations. And because metformin is known to decrease triglyceride level in humans. And again, that is an important mediator for several things, for deposition of fat in lipids in adipose, as well as in the ovary as well, in the growing follicle as well. And you can see a decline in a precipitous drop in triglyceride within 5 weeks of treatment. And again, it stayed the same way. The triglyceride levels are much lower along the entire treatment period. So we followed whatever COB 500 management guide told us in terms of feed restriction, how much of feed that needs to be given to these animals. So we are also now thinking of increasing the feed level, at the same time giving metformin, so that the animals get more energy. We have to keep up with the genetic selection, like what Grigori was saying, that the genetic selection has maximized the production, but we are not increasing the feed allowance. So if we increase the feed allowance at the same time without having a deleterious effect on the ovary, is there any way we can do it with metformin? So that's what we are heading towards. And this is my last slide. And this is sort of a model that I want to put together, because I see there is a very close connection among these three organs: adipose, liver, and ovary. And if at all, if we provide energy that is in excess of demand for optimal egg production, we end up with a lot of fat, right? A lot of abdominal fat, and then hepatic steatosis. You can see the color of the liver, it's a lot of fat in there, right? So you want to have a liver, something like this. And so for a practical purpose, what are the things that we could use in the next several years or decades? Of course, precision feeding. And along with precision feeding, is there anything that we could do to maximize egg production? Is it metformin or any other compound that could work in the liver and adipose or in the ovary to increase fertile egg production? The most expensive adiporon, the adiponectin receptor agonist, is it going to be available at a cheaper rate in the future, which is not going to be having any adverse effect in terms of animal health or production? PPAR gamma agonist that has been very commonly used in humans for a very long period of time to treat diabetes. Can we use them, repurpose them in chicken? Or even a specific feed ingredient like omega-3 fatty acid rich feed. Is it going to affect any of these pathways to have a balance of lipid oxidation and lipogenesis, increasing insulin sensitivity, right? Decreasing gluconeogenesis, particularly decreasing pro-inflammatory cytokines from the liver. So I put arrows in both ways because they communicate all the time. And at the same time, I want to emphasize it is the estrogen coming from the ovary and smaller follicles going to be affecting function of liver to produce many of these yolk precursors. With this, I'll stop and invite questions. Thank you very much. I have one more slide. Give me 1 second, please. Yes. Okay, I would like to thank, my graduate students, current and previous graduate students, and also the funding from U.S. Department of Agriculture and Pennsylvania Department of Agriculture. Thank you very much.
All right, thank you very much, Ramesh and Gregory. I would invite Gregory to turn on the video. Yeah, thank you very much. So we've got about, it's 9:30. We are going to pass the time, but again, we have some time for questions and answers. So I would encourage audience to put their questions in the Q&A box. So I got a question. I think, any of you can chime in. The question is, what is considered obese today for Ross 708 hens? Is that 2 pounds over the aviation standards? Maybe you can start, Gregory.
Yes. So as I said, I'm not really a specialist on the broiler breeder side, but I can, to address that question, really, it's hard to say 2 pounds, not 2 pounds, because it's going to depend when. When are you looking at that obesity? So what Martin has shown lately is actually during that early growth period, a lot of that energy is used for lean mass. And if you look at broiler breeders today, they are way leaner than what they were about 10 years ago. So I don't really think obesity is actually really an issue these days, except if you would relax totally feeding ad libitum. And can we relate that to a specific body weight? Yet it's going to be related to the specific body weight. But again, the body composition may differ depending on your management practice, and especially how you feed your birds. One thing that comes to mind for me is I had a discussion with Martin when he was using his precision feeding system. And he was giving relaxed or more nutrition, more energy in an effort to make them obese. And it turned out that they were just getting bigger and leaner. And the fact is because with the precision feeding system, they had those small meals, repeated small meals that doesn't overwhelm suddenly the liver all at once to put that energy in storage. So to your questions, I don't know if I would say 2 pounds, and maybe Mohammed's been working more with those recent lines. You can add to that, but I would say it's really depend on the age and as well what is the feeding paradigm.
Sounds great. Thank you very much, Gregory. So we've got some questions about metformin. So one of the questions, actually Ramesh answered it, but if Ramesh, you can just speak out. Do you think compounds like metformin could help relieve feed restriction at sexual maturation age and allow proper onset of egg production and overall reproduction? And also we have a question about, if it is available on the market based on the vet prescription. If you can touch on that, yes. That would be great.
Yes. So for the first question, absolutely. And I think we don't need to feed the chickens, the broiler breeders metformin all 45 weeks of production age. Instead, we could tailor it in such a time, tailor it to a time where we can relax feeding, we can give them more feed, more allowance. At the same time, by that way, you can advance maturation and sexual maturation and also egg production without having any deleterious effect. So yes, absolutely possible to fine tune this in terms of timing, when to feed them. That's question number one. Question number two, yes, at least in the US, you can get it. We have been getting it through our vet, through the vets from Midwest Veterinary Supplies. And I think that company is bought out by another company now. Yes, you can buy veterinary grade metformin. And of course, it is used in cats already, so you can get it. We buy in bulk a kilogram sized jar. These are 1 gram tablets. We powder them and then mix it with feed by ourselves.
Sounds great. So one question that I was wondering, So I'm just wondering if you can comment on the possibility of designing a point of care device, something like portable blood glucometer, to measure metabolites at the flock level.
Wow.
Maybe
that's really-
Gregory can chime in, or Ramesh. Yeah.
Go ahead, Gregory, you go first.
Well, I wish we I wish we could. Right now, unfortunately, it's not that widespread. I mean, the technology is there because, as you know, if we look at human medicine, you have a lot of those snap tests or those, for example, just looking at blood glucose level that are widely accessible. So I'm sure that's possible. Whether this is actually on the market, I'm not sure. Now, regarding the metabolites, blood metabolites, I was very intrigued by Ramesh about the omega-3 story, because PPAR gamma is one target that we have been looking at. It's kind of ubiquitous. That receptor is present in all those key organs. And because omega-3s are ligand for that receptors, I would be interested to follow the level of omega-3 fatty acids a little bit more closely, if you ask me what I would look for.
Yeah,
So,
sounds good.
just to add what Gregory was saying, yeah, we do have continuous glucose monitor for humans for now, and adding another metabolite over there, it is futuristic, and I wish we get that soon.
Yeah, sounds great. So we have a question. Do you think nutritional strategies to aim for low body weight can be as efficient as metformin?
I would say low body weight, not to the extent of affecting sexual maturation, because we all know that you need appropriate amount of somatic growth and adiposity for optimal egg production. So whether it is through feed restriction or using metformin, I wouldn't recommend lowering body weight to a greater extent. We want appropriate amount of body weight, appropriate level of body weight, not lower.
Actually,
and what is that appropriate is
Yes.
kind of, up in the air, that we need to decide on by trial and error and see which one gives you the most chick output.
Yeah, sounds great. So actually the question is about low body fat, not body weight. Yeah, body
Right,
fat.
sorry. Okay. Low body fat, yes.
Mhm.
I would say that, yeah, we should go for that. For a very reason, the lower the amount of, or an adequate amount of fat keeps the adipocytes in correct size, so that they produce anti-inflammatory cytokines in balance, so that you have all those advantages coming out of adipose tissue. Is good. We always incriminate that as a bad substance, fat. No, it's not. It is such an important organ, and we want it to be healthy. So it's better to have low level or adequate level. So not extremely emaciated, nothing there. That's going to be a condition that you commonly seen in human lipodystrophy. And we don't want a lipodystrophic condition. We want lower, we don't want to that extreme high, but we want adequate level.
Yeah, sounds great.
And Mohammed, can I just
for sure.
build on Ramesh? And I think the key here, sometimes when you use the term low or high, it's a little bit misleading, because what is appropriate? And as I mentioned earlier, I think appropriate depends on the stage of life of the animal. And if you get too low, this is not going to work, because you're not going to have enough reserve, enough signaling to tell the ovary and the rest of the body that the animal is ready to enter reproduction. The problem with the broiler breeders is they can't control themselves, because their appetite is so big that in fact they will tend to binge eat. And so if you relax the feed restrictions, they will eat too much too fast, and that will lead to overaccumulation of fat. So I think on the management side, it's going to be really important for the breeding companies to look at that pubertal growth and see actually what is the important and appropriate amount of fat, and to adjust the feed restriction accordingly to ensure that we've got that appropriate level at the right time. And as Ramesh said, after that, once you enter lay, if you leave them ad libitum, they're still going to be hungry and they're still going to overeat. So then this is when you need to intervene, and potentially with the metformin.
Yeah, awesome. So we have another question. What was the feeding schedule during the rearing or lay on the metformin fed birds? Was it daily or skip a day feeding?
Daily, it was fed once in the morning. And it is the exact recommendation, whatever COB 500 manual tells us based on the body weight and for the age and egg production level. So it was given daily. And the birds finished eating within like 45 minutes after we put the feed in the trough.
Yeah, sounds great. So my final question, maybe for both of you, how would you translate your research outcomes to a producer? Maybe Ramesh, you can start.
Yes. As I told you during my presentation, we want to marry basic physiology to production. And I have that in my focus all the time. How is this possible? And that's the reason I even said, okay, recombinant adiponectin, I made it, but is it practical? It's not going to work. So I think we should, as basic scientists, we want to have a solid understanding. We want to develop a solid understanding of basic physiology, right? And then see what we could adapt or where we could help the producers in terms of modifying the diet or adding certain compounds in the diet to maximize production. So that is where I see where we fit in. Although I do basic research, I always have that in my mind, how we can improve production in a long period of time.
Yeah, sounds great. Gregory, we appreciate your insight.
Yes, so I'm going to start as usual with the layers perspective, because this is where I've done most of my research in layers. And in the case of layers, it's kind of the opposite of the broiler breeders. So they were selected for egg production, primarily not for body growth, but what we observe is by selecting for advanced entry in lay, we have de facto selected for hens or for pullets that reach that metabolic status earlier, quicker. And for the layers, that was really a matter of re-coordinating the photostimulation, so photo period, with the body weight curve. Now, the broiler breeders, it's kind of the opposite because they use their energy more so for muscle mass, so for lean tissue. And hence, this is why you're not going to photostimulate a broiler breeder at 17 or 18 weeks of age. You have to wait until 22, 23 weeks of age. Otherwise, it's not going to work. So, pardon, my recommendation is really to revisit this growth trajectory to try to re-coordinate the body composition, the body growth with the photo period.
Yeah, sounds great. Yeah, that was really interesting discussion. I really appreciate it. And thank you very much for your great presentation, Gregory and Ramesh. And I think we hit the end of our webinar today. So remember that you can stay on FeedLoop to chat with other people, and also feel free to participate in peer board discussion. And thank you again for joining us today. And I hope we can see you on our next webinar next Thursday. And the question for our next webinar is, how do global feeding practices affect the sustainability of the industry? So thank you very much again, and take care.
Thank you. Bye-bye.
Thank you.
Yeah.